Today I'm going to be talking about the evolution of Wi-Fi, or the next evolution of Wi-Fi, so Wi-Fi 7. So who here has heard about Wi-Fi 7? Okay, it's not bad, not bad. A few people, a little spattering. Today, typically, people are deploying Wi-Fi 6 or maybe Wi-Fi 6E as the latest kind of standard, but Wi-Fi 7 is out there, especially in the consumer market. There are already devices out there, access points. So some of you may have already been using these at home, for example. So has anyone got Wi-Fi 7 at home? Anyone being tempted by these super looking home Wi-Fi 7 routers with lots of antennas, flashing lights? No? Blimey, I'm surprised about that. Anyway, so that's what we're talking about today, having a look at the evolution of Wi-Fi. In terms of, we're going to take a little bit look back, see the evolution of Wi-Fi, so where it's sort of come from very briefly, where it's heading to as well. We're going to look at Wi-Fi 7, so what the evolution of technologies in Wi-Fi 7 are, what makes it better, faster, increased capacity, reliability, resilience, and so on, and what benefits potentially it can bring to the education market as well. Then we're going to have a look at the 6 gigahertz spectrum. So this was something that was added after Wi-Fi 6 came out, was the addition of 6 gigahertz spectrum to provide more capacity. So it's very welcome in terms of doing that for high density deployments. However, it's not as widely used so far as what it might be. So Wi-Fi 7 encompasses the 6 gigahertz spectrum more, but it's not actually mandatory as part of Wi-Fi 7. You can still have access points for the just 2.4 and 5 gigahertz, for example. Then we're going to take a quick look at the roadmap. Now, unfortunately, I didn't realize this was being streamed, so I've actually had to take out some of the roadmap slides because we can't make them public without NDAs and stuff in place. So I'll talk a little bit about our first Wi-Fi 7 AP that's coming out, but unfortunately, I won't be able to talk a little bit more detail about the rest of the products that we've got planned over the next couple of years, unfortunately, Miss. And then we'll finish up, obviously, with a Q&A session. So just looking at the timelines, obviously, Wi-Fi has exploded over the last few years in terms of its use, and it's not just for connecting devices like laptops and tablets and phones and so on. There are also IoT devices. So whilst IoT generally may use Zigbee or BLE, for example, a lot of IoT devices also use Wi-Fi. So there's been a huge explosion in terms of the number of devices that are connecting to Wi-Fi. And each user typically doesn't have just one device they're connecting, they may be connecting 2, 3, or 4 devices, or even more than that as well. So in places like student accommodation, for example, we're seeing that they typically provision at least 10 to 12 devices per user. And some of those devices may typically be also not just things like printers, but there may be IoT-like devices, speakers, other types of devices as well, gaming consoles and so on, depending on the use case. So whilst within a school, actually on the school premises, you might not get so many devices per student or per teacher. Overall, the number of devices on Wi-Fi connected to Wi-Fi is still continuing to go through the roof there. So we've seen the generations of Wi-Fi. So a lot of people were familiar up until about 11AX. Most people were kind of familiar with the IEEE names, so like AC, 11N, 11G in the early days and so on, 11A. Most people were familiar with the standards name. And the Wi-Fi Alliance, who looks after the certification process for Wi-Fi and interoperability, they decided to start giving it a name that was a bit more kind of friendly. So hence we start to see Wi-Fi 6 came in, Wi-Fi 6E, now Wi-Fi 7. So we're really just at the start of the journey of Wi-Fi 7, as you can see here. And we'll see there are already devices out there. There are sort of like draft standard devices out there already that you can purchase, typically in the consumer space today. But Wi-Fi 7, what it's about improving the capacity further on your Wi-Fi network. So having more devices connected, having a better guaranteed or a better bandwidth for each device that's connected to your Wi-Fi network, better reliability, better battery life, better quality of service as well. So that's really the key focus areas for Wi-Fi 7. And as you'll see there, Wi-Fi 7, it's a technical term from IEEE, is 11BE, but you'll also see it's known as extremely high throughput. So we've moved from very high throughput, high efficiency, to very high throughput in terms of what it's trying to achieve. But it's more about providing more bandwidth per client device, so improving the capacity overall. In terms of the timeline devices, say, even right from the end of last year, there were some, pre-standard devices available there. So typically in the consumer space, Obviously, you've got things like some of the large Chinese brands out there jumping on the bandwagon of Wi-Fi 7 fairly early. But in terms of consumer devices, end user devices, that's typically where they were really positioned. That's typically what you see with any Wi-Fi evolution, is that it starts in the consumer space first and then comes into enterprise much later on. So we've started to see during the year, that some of the enterprise players in terms of devices have started to launch their Wi-Fi 7 offerings there. So, you know, from PC perspective there. And really, we're just at the cusp now of actually having enterprise AP. So that's ourselves, like Ruckus, the HP Arubas, the Extremes, those sort of vendors that play, Cisco, obviously Meraki, that play in the enterprise space from a Wi-Fi perspective, just starting to release their Wi-Fi 7 APs. So our first one has been announced, our R770 AP, Wi-Fi 7 AP, which is a premium AP that I'll talk about later. So that's been announced and will start shipping later this year. And then through the coming next sort of 18 months or so, we're actually going to see that all of our products will be refreshed. So the whole product family, all of our APs, our indoor APs, our outdoor APs, our specialty APs, will be all refreshed to Wi-Fi 7. So that's what you'll also see from other vendors as well. That, you know, they'll start over the next sort of 15, 18 months or so, refreshing all of their product lines to Wi-Fi 7. So just as you start to get comfortable, you know, most people I think are familiar still with 11AC and Wi-Fi 5, Wi-Fi 6. A few people put their hand up knowing about Wi-Fi 7. But what you can see here is that the sort of certification standards and Wi-Fi Alliance have defined a bit more of a time frame for future evolution. So you're looking at roughly about a four-year gap to the next evolution of Wi-Fi, which is going to be Wi-Fi 8 or 802.11bn, and then you've got Wi-Fi 9 on the heels of that, you know, going out in 2030s. By which time, hopefully, I'm retired and I don't really care about it anymore. But we'll see. See how much Ruckus stuff you buy. Help me along in those sales figures. Yeah. But yeah, so it's continued to evolve. You know, up until really this sort of time frame of 11AX, 11BE, so Wi-Fi sort of 5 and Wi-Fi 6, it sort of just seemed to creep up and suddenly happen. But there's a bit more of a defined timeline now on those future evolutions of Wi-Fi. So, I mean, for you guys, you know, as customers, it helps you to sort of plan and think about when you might want to, you know, update, renew your infrastructure, how long you may want to kind of continue to sweat your current assets, waiting for the next evolution to come along. So Ruckus has actually been very active with the Wi-Fi Alliance. As I said, they're the body that actually does all the certifications, so interop testing between APs and client devices, and certifies them to make sure they do what they're meant to do, and that they do interoperate and they do connect together and play nicely together. So most devices, you know, client devices, laptops, access points, even controllers get certified by the Wi-Fi Alliance. So they go into a test bed. So Ruckus has actually got an access point. It's based on the R770, which I mentioned is going to be available later this year. It's a slight modification to that. It's actually a higher spec capacity just for the Wi-Fi Alliance testbed. But currently, we are the only vendor in the Wi-Fi Alliance testbed that's going to be interop tested against all these other client devices. So, you know, that's a really important thing that, you know, Ruckus, you know, work so closely with the Wi-Fi Alliance from an interoperability perspective, and are trusted as a vendor by them for delivering interoperability testing with client devices. So that's a pretty important thing that's very good for us. So just taking a look at the technologies and the benefits of Wi-Fi 7. So this is just a bit of a comparison between Wi-Fi 6, Wi-Fi 6E, which is the 6 gigahertz extended spectrum version, and the upcoming Wi-Fi 7. So you can see there the sort of date lines of when the standards were actually ratified and certified by the Wi-Fi Alliance. So for Wi-Fi 7, we're not expecting to see the certification plan complete until March of next year. So, you know, kind of everything that comes out is effectively still draft standard today, whether that's clients or access points. In terms of frequency bands supported, so Wi-Fi 6 supports 2.4 and 5 gigahertz bands. Wi-Fi 6E supports 2.4, 5, and had the addition of a 6 gigahertz to it. So really the 6E stood for the 6 gigahertz band, or the extension to 6 gigahertz band. With Wi-Fi 7, it can operate in any of those frequencies. So it's not mandatory, as I mentioned earlier, to have to support the 6 gigahertz band. You can still have access points, and we will have some more entry-level access points for only 2.4 and 5 gigahertz, for example, which will come in at a lower price point than access points that also support 6 gigahertz, because obviously more radios you have, the more expensive the product is. And you see here some of the technical specs of what's actually increasing in Wi-Fi 7 in comparison. So you have more radio streams potentially, so have more radios. There is no plans to release an access point with 16 radio streams in it. So as you may have seen on the previous slide, the 880 will actually have 8 radio streams, but there's not any plans at the moment to productize that by any vendors, because fitting that number of radios into an access point would make it, probably the size of this podium here. So, and draw the power that's requiring its own little generator to run it. So no plans for that. Typically we'll see between 2 to 4 streams as you do today. So whilst at a high level, this adds a lot of capacity, in reality, you're not going to see the full benefits of that. QAM is the modulation. So this is how the data is actually modulated onto the carrier RF signals that go out across the air. So increasing the number of symbols or bits that can be encoded onto that carrier obviously increases your performance and your capacity, because the more bits of data you can encode on one bit of signal, the more data you can actually carry. So that's a pretty significant increase in the number of bits that you can actually, or symbols that you can actually carry at the same time over that RF wave. Channel width is something, it's actually how wide the amount of spectrum that you actually have available. So going from 160 to 320 megahertz obviously doubles, effectively it makes your motorway twice as wide. So you can carry a lot more data at the same time. It does come, of course, with some limitations, because you need to have the available spectrum with no interference to be able to use those wider channels effectively. So today, most deployments will still be using 20 or 40 megahertz, maybe 80 megahertz wide channels in some cases. But there may be some situations that you are able to use these wider channels like 160 or 320 megahertz. And I'll talk about a feature in Wi-Fi 7 called punctured transmissions, which actually allows you to make more efficient use of these wider channels when you actually have interference in a part of the spectrum that it's actually using. So that's quite a nice feature of Wi-Fi 7 that's coming up. And then you can see the sort of high line improvements in performance. So we're talking about physical data rates here. So this is maximum physical data rates, typically depending on which of these features are being used, how close to the access point you are, what the client capabilities are as well. They have to be matched to the access point. These are the headline kind of numbers in terms of throughput. Probably the bottom one is the best indicator there, because that's more in line with typically what you'd get as a high-end AP today, and maybe a high-end client device, or maybe doing wireless meshing between access points somewhere as well. So you want to get best bandwidth between those meshed access points. So something like 4x4, doing just under 10 gigabits per second, which means theoretically you'd probably be able to get somewhere 4.5 to 5 gig potential throughput, actual throughput from that in best conditions, in most optimal conditions. So we've looked at these in the top left there. We've already looked at those. So the QAM, the wider channels, and so on. So that's one way that Wi-Fi 7 performance would significantly increase, and not just performance. We're not just talking about increasing performance on a per client device basis. We're talking about increasing the overall capacity of the Wi-Fi network. So allowing more clients onto the network, and each of those clients having higher individual bandwidths as well, because generally that's what you want when you're delivering real-time learning and applications, streaming, augmented reality applications. You need high bandwidth and low latency to be able to do that. This is what I just mentioned, punctured transmissions. So if you're using wide channels, so this is effectively showing you if you're using a wide channel here, maybe 160 or 320 megahertz wide channel. In today's Wi-Fi, if a part of that is interfered with, so to speak, part of that frequency is interfered with, then what's going to happen is it's going to basically make a whole part of that spectrum unavailable. The access points and clients aren't going to be able to use that, so that's going to reduce probably the reliability to a degree. It's also going to reduce the capacity of the AP on that particular channel. So it's basically like you're going down the motorway, one of the lanes is shut, and that's having a knock-on effect on 2 or 3 of the other lanes as well. It's not just the lane it's on, it's actually affecting other parts of the roadway as well. So with punctured transmissions, what it's able to do is to actually recover unused spectrum as well. So spectrum from the base channel, or the actual base channel that's used for that part of the spectrum, if part of it is being interfered with, it can actually recover after that source of interference or whatever's causing issues in the spectrum to actually utilize it. So going back to that example on the motorway, you've got a lane closed because of a breakdown or an accident. It's only that lane that's being affected. The rest of the lanes are still open to be used. So you still maintain a high level of capacity compared to previous releases of Wi-Fi. So that's a pretty good feature. We've also got this new concept. So it's coming from the wired network, whether that's kind of switching within your local network or maybe having multiple internet connections and so on. There's this new concept of doing multi-link or link aggregation within Wi-Fi 7. So what this allows you to do is to actually aggregate different radios on different channels together to do various things. So you may want to be improving your reliability, you may want to be improving your bandwidth, or you may want to be determining which link is best for low latency traffic. So real-time type of traffic that's important. You may want to use 5 gigahertz for that and use 2.4 gigahertz for other traffic, background traffic. So that's really a pretty good feature of Wi-Fi 7 as well, this ability to link together different radios operating in different channels to increase your capacity, reliability, and potentially reduce latency as well. Then enhanced quality of service. So this is just about being able to, going back to that, being able to prioritize time-sensitive traffic, so real-time applications, virtual reality type of applications, maybe remote learning, whatever it may be. So you may be streaming stuff within the classroom. It may be you're streaming stuff to a different room in the classroom, for example. So if you have time-sensitive traffic, it's the ability to actually prioritize in a much better way that time-sensitive traffic than's been possible in Wi-Fi networks before. So again, this is all about reducing the latency and making applications behave much better than they used to on Wi-Fi networks. In terms of early adopters for Wi-Fi 7, these are some of the markets that we play in. So education is a very big market for Ruckus. So hopefully quite a few of you people already know who Ruckus are. And hopefully anyone here actually use Ruckus, I should have checked. Need a few more hands in the future, please. Go and see Net Control. Yeah, education is a very big market for Ruckus in the UK. Also things like hospitality, so hotels, as well as MDUs, so multi-dwelling units, so that's things like student accommodation, military barracks and so on, and large public venues, stadiums, conferencing centres and so on. But we're seeing, for example, in education, we're seeing that Wi-Fi 7 may be adopted fairly quickly in education for the reasons of that capacity, the lower latency, those improved features that I've just talked about, to improve the Wi-Fi experience, especially when you're adding more and more devices to your Wi-Fi network and applications that are more latency time sensitive as well. But more so in education is that typically, especially if they're BYOD networks, is that the students have newer devices. So, it's great that you've got Wi-Fi 5, but your students are coming in with Wi-Fi 7 devices to connect to the network, and they're not getting the benefit of, those improvements in terms of capacity and performance and so on. So, quite often in places like school networks, BYOD is a driver of actually upgrading your Wi-Fi technology. So some of the use cases in education, I've already talked about some of these. So, who here goes to bet? Quite a few. So you go to bet, and I mean, it's a mind-boggling array of tech gizmos for education and stuff. When I go around schools with some partners and do site surveys and things and help out, I don't see too much of this deployed currently, but these people at Bet must be selling it to someone, I guess. I'm not sure who sometimes. But there are drivers there. So things like doing virtual reality, augmented reality, it is coming, it is developing, it is coming down in price. So you may see more of that. And that's used in education. It may be for purely sort of delivery of educational things with virtual reality. It may be to actually work together on projects, not necessarily being within the same classroom. So augmented reality, actually collaborating together in real time, where you need really high quality Wi-Fi for doing that with great performance as well. So e-learning applications, obviously across your Wi-Fi network, virtual lessons. We're all kind of familiar with that today, sort of post-COVID. Some of that still goes on. Esports, don't know if anyone here is involved in esports. That seems to be a growing market as well. Seems to be something that's growing in education, esports. And obviously it's kind of done. I thought esports was kind of like, Wii, Wii Sports. So it's like you're actually playing computer games, but you're actually doing something active. I was wrong. Basically, esports encompasses any type of gaming, really, which I was surprised. So you can actually just be sitting there on your butt and not actually doing anything particularly active apart from gaming. I thought it actually meant sort of participating in virtual sports. I was wrong. But anyway, esports part of that. And obviously, high resolution video, we are seeing sort of 8K video streaming and so on coming along. So if you need to stream high resolution, then Wi-Fi 7 is a solution for that. And we've already talked a lot about the sort of technologies of Wi-Fi 7. And this is really some of the things it helps to deliver to allow you to run those sorts of applications over a Wi-Fi network in your schools. So you need that low latency for those real-time applications. You need reliable connections, and that's something that Ruckus has always been good at providing. Consistent performance for each device. So this is where I was talking earlier about it's not how fast an individual client can go. It's about when you've got 30 clients on your AP, the bandwidth that they all have, and that consistent, reliable bandwidth and connection they all have across there. Extending battery life as well is important. So there are technologies in the evolution of Wi-Fi 7 to help improve battery life for devices, mobile devices. And overall, obviously, your Wi-Fi network needs to be simple to deploy, manage, and configure. So we have some features and functions within our different controller platforms for helping you do that. So moving on to that subject there. So, AI, machine learning, they're all big subjects that are talked about by, vendors in all sorts of spaces and markets. So not just obviously in Wi-Fi, learning applications and so on. AI obviously comes into that, student safety. But we're making a big push into the AI side of it. So we've had an application called Ruckus Analytics, which is all about helping to troubleshoot, monitor, optimize your Wi-Fi network, alert you to issues and so on. So we've had that for probably 2 to 3 years now. That's been running Ruckus Analytics. And that's a bolt on to our Smart Zone controller. We've just recently released our Ruckus One, our new cloud platform, and that includes the AI stuff built into it. So it's all there to help you troubleshoot your network, fault find it, flag issues where it's going outside of the normal sort of baseline of operation, and also provide you with easy optimization of the network as well. So it kind of samples the baseline, and it can actually give you information on how you can improve your Wi-Fi network through AI recommendations. Going back to reliable, great performing, reliable Wi-Fi with great coverage. Really the mainstay of Ruckus has been our smart antenna technology known as beamflex. I'm going to delve into that, but we've got lots of technologies where we differentiate ourselves from our competitors by using smart antenna arrays. And then, we concentrate on trying to deliver the solutions that actually help our customers in our market verticals, so in terms of education. So we try to help focus products and how things actually work and optimize to work well within those environments that we serve. And, for the users, they don't really see the background technology. They don't care about the network. When something's not working, it's the Wi-Fi's fault today. There used to be, it's your broadband's not working, whatever it may be. Today it's always, if there's any issues from a user perspective, it's always the Wi-Fi network's the issue. It doesn't matter really what it is, but it's always the Wi-Fi network. So the users don't really care what the technology behind it is, but all these features that we have and functions, and Wi-Fi 7 is helping to drive that more reliable, lower latency Wi-Fi networking, to help these different types of applications that the students actually find cool. So just taking a quick look at spectrum. So a couple of years ago, we had a big block of spectrum added in 6 gigahertz. So it's previously 2.45 gigahertz for spectrum. That was starting, even 5 gigahertz was starting to become limited in terms of when you had a large number of access points in close proximity, so maybe an access point in every classroom. And if you wanted to use wide channels, it was starting to become a limitation. This block of spectrum was added to help improve the capacity of Wi-Fi. In the US, they actually got about 1.2 gigahertz of spectrum. In the UK/Europe, where we're fairly well harmonized, it's about 500 megahertz. But it's equivalent to about the same number of channels as you get in 5 gigahertz today. So you kind of effectively doubled your 5 gigahertz capacity by adding 6 gigahertz to it. So basically, with this new spectrum, there's less sources of interference. There's not some of the legacy stuff like getting 2.4 gigahertz, for example. It's not previously been used for Wi-Fi, so it's not that utilized by Wi-Fi. But we will talk about some other things that might interfere with 6 gigahertz. And with 6 gigahertz being a cleaner spectrum, having more frequency to work with, it helps to deliver multi-gig speeds. It helps to improve the latency and reliability. So for your deployments in schools, it allows you to, if you've got applications that are very data heavy, it allows you to move that data more quickly across the Wi-Fi network. It improves reliability because there's less sources of interference. It makes the applications more responsive, so lower latency again, and more reliability there as well, and allows you to connect more devices than you previously could per access point. So you get more bang for your buck to a degree, whilst the CapEx cost of your access points will be a bit more because it's got an extra radio in it. You can actually connect more devices to it. Where it starts to get a little bit more murky and grey and tricky is that there are some incumbent operators. So things like some of the TV services use fixed uplinks. There's some military stuff that uses 6 gigahertz as well, and that's typically outdoor use. So you're restricted to the power that you can actually use. So there's 3 power modes. You've got very low power indoors, low power indoors, and standard power. So you can see that there are restrictions on what the actual power limits that you can transmit in those modes are, and where you can actually use them. So today, typically, we can only use the very low power and low power modes in the UK. So Ofcom haven't put in any system in place to allow you to use standard power. So you can't use Wi-Fi 6E, the 6 gigahertz spectrum outdoors. You can only use it indoors currently, and you can only use low power. And if you look at the power there, the 200 milliwatts ERP, so for you guys not familiar with RF, it's just the level of power that you can actually transmit, the maximum level you can transmit. So that's actually quite low. If you compare to 5 gigahertz, there are some channels that you can do 200 milliwatts. There are other channels that you can go right up to 1 watt in terms of transmission. So it's relatively low, and the higher frequency of 6 gigahertz means that it gets more attenuated. So you have the problem like when you went from 2.4 gigahertz that had very, very good coverage. It went through walls and concrete and stuff fairly well because of the lower frequency. When you went to 5 gigahertz, you suddenly found out that actually you needed 15% or so more APs because 5 gigahertz doesn't penetrate the high frequency, doesn't penetrate through walls and so on, as well as 2.4 gigahertz. So with 6 gigahertz, you kind of go back to that problem. So that's something you have to consider as well, is that high frequency attenuates more. So in the US and Canada, to get around this only being able to use low power modes, to be able to use standard power, higher power, use it outdoors, they've developed this system called AFC, so Automatic Frequency Coordination. So what this does is that basically the AP stroke controller will query a federated database that will tell them what spectrum is available in 6 gigahertz for that location. So the APs or controller, they need to be aware of their geolocation. So our new Wi-Fi 7 APs, for example, will have indoor GPS functionality in them, so they can be kind of located automatically indoors within a particular area. So what this does is it basically the controller or the APs will query what spectrum in 6 gigahertz is available for them so they don't interfere with the incumbent services out there already. Unfortunately, Ofcom has so far not decided to release a system like this, and until they do, it means you still can't use standard power to reduce the number of APs you need indoors or use it outdoors either, unfortunately. So, you're still going to be constrained for the time being in the 6 gigahertz spectrum. So just some more constraints of that. It's not, in terms of sort of the other regulatory bodies across all the other regions, the 6 gigahertz spectrum isn't fully harmonized. So in some countries or regions, 6 gigahertz isn't available at all. Some places, they use different parts of the spectrum rather than the same parts we do. So it's a little bit of a mess from the spectrum perspective. I mentioned, so no AFC-like solution for the UK, and I've seen nothing to date so far that suggests Ofcom is going to be delivering one. So using that low power mode reduces propagation of the RF. So you need to decide whether you're going to build your Wi-Fi network to provide full 6 gigahertz coverage if you're going to be doing that, which means more access points, it means more switch ports, it means more power required as well, more cabling required if you're going to go full 6 gigahertz coverage everywhere. Or maybe what you want to do is actually just say that I've got some high density areas, the assembly hall, the refectory, for example, the dining areas. Maybe they are high density areas where I want to use 6 gigahertz, but for the classrooms, they're not such high density, I don't need to use 6 gigahertz there. So you may sort of do a pick and match on where you actually want to use the 6 gigahertz spectrum. So that's just a little bit about the designing. Sorry, didn't get to that point on there. And obviously, if you've got only, if you've got legacy clients that only support 2.4 and 5 gigahertz, they can't connect to the 6 gigahertz band. But typically, any newer clients that support 6 gigahertz will be backward compatible with 2.4 and 5 gigahertz. So yeah, sorry, I've had to kind of skip past the slides on all our plans for the new access points, but I will talk a little bit about the R770 because that has actually been announced. So this is a premium, so like a high-end Wi-Fi 7 AP, so tri-band, operates in both 2.4, 5 and 6 gigahertz. It also has a dual band mode, so you can basically operate it if you only want to in legacy bands, so 2.4 and 5 gigahertz for now, if you don't have any 6 gigahertz clients. So I'm not going to go through all the stats in here. I think the other important part, so this is going to be shipping and available for ordering towards the end of this year. We're pretty well one of the first in the industry to release an enterprise Wi-Fi 7 AP. And in terms of management platforms, that's also another important note down the bottom there as well. So for anyone who is a Ruckus customer or looking to become a Ruckus customer, the smart zone is so it's a physical or a virtual appliance. That's our kind of mid to large enterprise controller. Support for that is going to be in February of next year. Ruckus One, which is our cloud offering, we're going to have support for this AP in December of this year. Then Unleashed, which is our small business controllerless solution, that's going to be available in Q2 of next year for this AP. And you'll start to see in Q1 of next year, which I can't show you on here, but you'll start to see in Q1 of next year that we're announcing more and more Wi-Fi 7 APs. So we'll start moving down to the mid and lower end of our product ranges there. So the more cost-effective ones that you typically use in education deployments. And of course, as I mentioned, with Wi-Fi 7, if you are going to 6 gigahertz, you've got higher throughput. So you may potentially need multi-gig ports on your switch network. So not one gig ports, they won't have sufficient capacity to connect your APs with 3 radios in them and high capacity. So you're potentially going to have to go to multi-gig. So you might need to be connecting to a 2.5 or a 5 gig port. As you saw, the R770 actually has got a 10 gig multi-gig port on it. So it supports 1, 2.5, 5 and 10 gig on it. You wouldn't need 10 gig of bandwidth, but certainly 2.5 gig is possible. So in terms of your switch network, if you're going to Wi-Fi 7 with 6 gigahertz, you may need to look at multi-gig switching there. You may need to look at higher power levels as well. Oops, sorry about that. Go that way. You may need to look at higher power levels as well, because 11AT for 802.3AT, for example, standard or PoE plus won't be sufficient to drive 3 radios on the APs. So you potentially have to look at BT power as well. So considerations of going up to Wi-Fi 7 and 6 gig is that you may need to upgrade your access switch network and probably your aggregation stroke core network as well. So Ruckus have got a great range of switches here with a lot of sort of heritage in them. So that's it. Thank you very much. So any questions? No, everyone looks dumbfounded.
So with 6 gigahertz being very much line of sight, we do deployments. How much is that going to impact? The Ruckus model is a big spacing. Do you think that's going to impact on the market share that Ruckus has in AP deployment?
So as you can see, BeamFlex still plays part of what we do. So we're not ditching BeamFlex. We still think it provides an advantage in terms of the reliability of connection, the performance of connection. So I think that the fact that Wi-Fi's got faster doesn't completely negate what Ruckus do with their smart antenna arrays, if that answers your question. That's still part of our DNA, the ability to do dual polarization as well, for example, making selections. So, whether your AP is on the ceiling or it's on the wall, we always provide the best polarization compared to the device's antenna and so on. So, I think BeamFlex is still very relevant in terms and those technologies, because we do all of our own things like rate adaptation as well. We've written our own rate adaptation algorithm. So a lot of other vendors, what they actually do is they just use reference designs. So they buy the chipset from Qualcomm or whoever it happens to be, the RF chipset, and basically that tells them, if you design your PCB like this, you use an antenna, omni antenna of a certain gain, this is the characteristics you can expect to get out of it. And then they basically use the RF rate adaptation stuff that's actually built into it. We actually do our own overlay layer, so we add a lot of extra value by actually optimizing all of our own boards. We do all of, you know, our own designs, obviously our antennas and so on. So I think overall, you know, Ruckus obviously isn't, you know, we're not in the prosumer brand space like, you know, your Netgears and your D-Links and some of the other players, obviously Ubiquitys. You know, we are in the enterprise space, and we do think we differentiate with our, you know, our actual radio technologies compared to our competitors, and, you know, continue to do that. Any more? Going once? Going twice? Done.
Thank you very much, Eddie.